Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from ScaleMP. We have the founder and CEO, Shai Fultheim. Welcome to the show today, Shai.
Hey Rich, how are you?
Great, great. I'm getting geared up for ISC, so I'm glad we could catch up and find out what you guys are up to. So why don't we start there, Shai? I've brought your slides up, and we'll go through that, and then we'll follow with a Q&A.
Excellent. So I prepared three things for you here. So first, a quick refresher. Okay. Second, what's new and exciting going on in the field these days. And third, I'll say the maximum we can say about the ISC. There are lots of interesting stuff we're going to announce there, and I'll touch on that last. How about that?
Sounds great.
Okay. So if you open the presentation, jump directly to slide number 2. As a quick refresher, ScaleMP provides software-based shared memory systems, virtualization engine that takes multiple systems and virtualize them as one big box. It's providing the largest SMP systems in the world, going all the way up to 32,000 cores and 256 terabytes of memory. It's processor agnostic, although in the market today our products support x86 and InfiniBand. We are working on other interconnects and other processors. Our product is out in the market since 2006 and is available by the hardware vendors such as HP, Dell, IBM, Fujitsu, Bull, and others. If you can see on the map there on our slide number 2, you can see that we have deployments all around the world, and the demand is growing. If you go to slide number 3, you'll see on the left-hand side some customer names, some customer logos, and you can see that it's going across the industry, across the board, from higher ed and research, life sciences, government institutes, manufacturing, automotive, finance, EDA companies, telecom, datacom, and so on. And from applications perspective, customers are running any type of application. From applications that are MPI, applications that are shared memory, applications that are large memory, single-threaded, multi-threaded, and quite a bit of homegrown applications. So whatever application you have and whatever segment you are, virtualization for technical computing can be the right technology you should use. And why is that interesting? If you go to slide number 4, we talk a lot about virtualization, but sometimes it's confusing. There are 6 companies in the world that provide virtualization for x86. The major 6 companies are VMware, Citrix, Red Hat, Microsoft, and Oracle, which allows taking one machine and creating multiple virtual machines on top of it. This is suitable for workloads that do not require a whole machine. It's suitable for workloads that require small part of a machine, and by using this partitioning technology, you can compress quite a bit of demand into a single physical box. ScaleMP, as the 6th company in that domain, provide a virtualization technology that targets high-end computing, workloads that require more resources than what one box can deliver. Whether that the amount of memory, the amount of compute, or I/O, in all cases where the workload needs more than what one machine can provide within its boundary, that's where we play. If you jump to slide number 5, that will give you a pretty quick diagram of the 4 most common scenarios. So we're starting from top left. There are quite a bit of applications that require lots of memory. They do not require lots of CPUs or I/O, but they require lots of memory. Let me give you an example. Velvet, a pretty known application in the bioinformatics space, it requires terabytes of memory. 1 terabyte, 2 terabytes. We have customers that need 4 and 8 terabytes of memory when they run Velvet. Surprisingly, it doesn't need lots of CPUs. So if you give it 8 or maybe 16 threads, that's enough. So with our virtualization solution, you can take multiple systems and create a large memory pool, allowing the application to use the cores of one machine and the memory of everything else. Another example, on top right, applications that require lots of I/O. Give you an example, Nastran. Nastran is an application that uses a small number of CPUs. but it requires lots of I/O. If you won't give it fast enough I/O subsystem for scratching, what will happen is your application will stall. Application will stall means that you don't utilize enough your licenses. You don't utilize your licenses enough, you're wasting money. On bottom right, I'll give you an example, application that need more CPUs than what one box can provide, but doesn't need lots of memory. Example, Gaussian. Gaussian will need quite a bit of CPUs. There are workloads, Gaussian workloads that scales to 32 and 64. We've seen even a little bit over 64 CPUs. But on the other end, the amount of memory, while it's significant, it's not more than 64 or 128 gigabytes. So one machine can provide that, but you need more CPUs. So you can create a VM that will give you that. Of course, in real-life scenarios, you'll find workloads that require large memory in some portions and I/O in post-processing and compute in main processing. It may be a combination, but virtualization can give you the ability to create these VMs that span across machine boundaries. You notice that I skipped the fourth case, but the fourth case is very interesting. The fourth case is the case where I'm running an application that can use multiple machines. It's designed for multiple machines, and we all know MPI applications that are designed to work on multiple systems. And with virtualization, we can simplify the working environment. Instead of having multiple operating systems to manage, we can have just one, consolidating our infrastructure through a single point of management. In the last year, we invested lots of efforts to characterize different workloads and report their performance on our virtual SMP technology. If you jump to slide number 6, you can, providing there the URL to our performance portal on our website. In fact, Rich, it's easy to remember. It's www.scalemp.com/performance. Guess what? And if you go there, you'll see 50 to 60 different performance benchmarks pointing to the strength of virtual SMP technology for applications that require more memory, more I/O, or more compute than what one machine can provide. So that's about technology. Now, let's talk about what's interesting for customers. Go to slide number 7. And on slide number 7, we see the 3 most use cases why people are using our technology. Starting from left, server consolidation. I have a cluster, I'm running Fluent, I'm running Abacus, I can run that on multiple machines, but I don't have the skill set to manage them. So I can virtualize my cluster as a super workstation. And now I'm going to run one machine and my workload is going to run in that context. In the second case, I need a big machine. I need a big machine with lots of terabytes of memory or many, many, many cores. And in that case, what a virtual SMP can give you is to create that machine at the most cost-effective manner. And last but not the least, on the right-hand side, the third pillar is pointing out to large-scale deployment where I'm going to buy a very large infrastructure that will cost millions of dollars, and I'm going to have hundreds of machines. And I'm looking for the most simplest way to run hundreds of machines and fulfill the demand required by any type of workload. And virtualization can assist on that case as well. Now, the interesting stuff in the market happens on the first case and the third case. Traditional big SMP machines are being bought primarily for large memory applications and for high core count applications as well. And our solutions in these markets are well known. I think we are the leading company today offering large-scale shared memory systems. But where the innovation happened, where we see more and more customers joining the paradigm is on the first case and the left case. And I prepared for you 2 quick examples for the first case and the first case, the server consolidation case, the cluster management case, and the cloud environment. So let's go into that. If you just move one slide to slide number 8, here is our typical cluster. If you look on the top left, that's our MPI cluster, right? I have my 4 servers. I have my favorite operating system on each one of them, and I have the 4 jobs, MPI jobs, the orange one, the blue one, the green one, and the black one. And I have a way to distribute them across the machine. And I have a fast fabric, and I have high-speed storage in order to accommodate that. And I need to have the skill sets to run that. I need to install operating system multiple times. I need to pay someone to come and put my high-speed storage. I need to do fabric management. I need to know all of that, or I need to pay for that on a monthly basis. In fact, it's very similar to what's happening in the enterprise when I'm running a cluster of VMs, right? Or multiple systems that run VMware or multiple systems that run KVM. It's all the same. I have multiple systems and I need to manage multiple entities. Jump to slide number 9, you'll see how we transform that using virtualization. Starting on the left-hand side, my HPC cluster has been transformed to a super workstation, to a single system to manage by putting virtualization, making a single operating system running on multiple machines. All my jobs are running there. Now I have one machine to manage. I don't need to deal with fabric management. Storage became much simpler. Single entity to manage, upgrade, and deploy. And that makes my life easier. And same is true on the right-hand side. Instead of running 4 machines, each one of them with their hypervisor and multiple VMs on top of that, and have the need to go and do load balancing and migration and all these difficult things that exist in that domain, I have all my VMs running in the same context. It's a very similar example. Why is that similar? We consolidate. We take multiple entities in an environment where I can use multiple entities. We run it as one, and we save money on the operational side. What we are seeing in the market, in fact, in the last year, is that more and more customers are buying into that. It's very easy to buy today technical computing software, whether that's ANSYS or Fluent or Abacus or MATLAB that runs on a cluster. But what you find out is that you buy the software for the cluster, and then running the cluster is just a nightmare. So with virtualization solution, you simplify it. You take the problem away. The second case I mentioned was the cloud. How technical computing, virtualization, and the cloud can combine together. Go to slide number 10. And what you're seeing there is how a large-scale technical computing data center looks like, right? We all buy these, 100, 200 node cluster, and next to that we have these fat node machines that have a little bit more memory, and maybe a big shared memory machine next to that to give us the high core count. It's a mixed infrastructure because, one size doesn't fit it all. You will have a Gaussian workload that can use 64 cores on one end, and you will run Fluent that can run distributed very, very nicely. So you want to buy the best machine for each workload. While that is a great utopia, on the day-to-day, what it will require you to have, you'll have high maintenance because you will have different type of machines. And it will be complicated to provision because the provisioning system and the job scheduler will have to understand this topology. And last but not the least, you need to take a big bet. And the big bet is what will happen 2 years down the road. Will 2 years down the road you need more horsepower for the distributed workloads, or will you need more horsepower for the shared memory, the large memory type of workloads? It's very hard to forecast the future, right? Otherwise, we wouldn't have been here, right? So with virtualization, if you go to the next slide, you can simplify that environment. You can have just a flat cluster across the board, add some software to that, as you can see on the right-hand side, and create these VMs when you need them. So go to slide number 12, and you see these VMs, okay, that are created on demand. And we recently won, together with IBM, a very large-scale deployment at the STFC Dartbury Lab in UK, where instead of having a legacy HPC infrastructure that combine clusters and large memory systems and a fat node systems and so on, a flat 512 node IBM iDataplex cluster has been deployed, and coupled with platform computing provisioning and scheduling tools, the customer can submit jobs to queues and will be able to create these VMs on demand. So if you submit a Gaussian job to a queue, a VM that has a 64 cores will be created. If you submit a Velvet job into a queue, a VM at the right size, whether that's half a terabyte, maybe that's a terabyte or 2 terabyte, will be created, and the job scheduler know how to create things like that for the different workloads. So that's great. Okay, that gives us an infrastructure that automatically configure itself on an on-demand basis, on a per-job basis. And I'm very, very happy both with that win and the work with IBM, and above everything else, the work with platform computing on integrating the platform computing offering with the ScaleMP virtual SMP offering that enable these type of capabilities. So that's it for the first two bullet points I told you at the beginning, and now we can jump into ISC. Are you interested to hear about ISC, or that was
Oh,
enough?
oh, absolutely, you bet.
So let's go to slide 13, and that's kind of summarizing what we are going to announce, and that's a big announcement. It's a big announcement for ScaleMP, and it's a big announcement for the industry. Now, I cannot go into the details, but I can tell you that we are going to launch a new virtualization technology. It's something different than what we have done so far. We invested the last 2 years in designing and implementing that. It will be revealed at ISC, which is within the next 30 days. It's 3 weeks from now, if I'm not mistaken. It's a breakthrough in the way we all, the technical computing users, are using the systems that we use. It's a breakthrough in the usage model. It allows to, I would say, to supersize, to blow out the amount of parallelization processors providing us. This new virtualization technology allows us to get to this high parallelization level without any code changes. It's amazing. When I'm looking at it, when our engineers kind of present that to me, it's just unbelievable that we can get to this high level of parallelization without doing any code changes and get higher parallelization level than what the main processor can provide. The unique thing about that is that if most of our customers today are in the server environment, we are targeting that technology to the desktop environment and towards big data problems. And when all the data will be revealed and the information will be revealed at ISC, it will be clear why that's the case. This is going to be a major announcement at ISC, and I hope I'm going to see you there and we'll be able to talk. It will be available for customer later in the year, so stay tuned. It's just around the corner, and it's going to make a big impact.
Oh, great, Shai. Well, I won't press you for more details. I know that you gotta respect the technologies of your partners and their dates. So, why don't we talk a little bit more about your current offerings then? Because I have a couple questions.
Sure,
Sound good? Okay.
sure.
Uh, you know, you talked about your benchmark page, right? And are you comparing generally there the systems that are using maybe virtual memory, going off to disk to run the problem versus the Scale MP virtualized system?
Um, yes, that's one of the scenarios. In fact, when we're looking today on large memory workloads, there are two options for customers. They are either can buy traditional systems, large-scale systems that are very, very expensive, or take the largest machine they can and put a very high-density memory. So that's one option. So let's do that using RAM and pay a lot either for the system or for the memory density, option number one. Option number two, let's take a regular system and just go to a disk and we'll use flash to accelerate these operations. ScaleMP technology, contrary to that, will use cost-effective memory. Okay, whatever the right memory, dollar per memory, dollar per gigabyte you'll pay. We'll just plug enough system in order to be able to swap in and swap out, quote unquote, memory between the systems. So there are quite a bit of comparisons to that, towards that. On the slides, there is Abacus examples and there are Gaussian examples on our performance portal that compare the use of disk versus the use of RAM. The use of RAM on large-scale systems and the use of RAM on off-the-shelf systems coupled with our technology, and the numbers speaks for themselves.
And with this broad swatch of customers that you have using your technologies for very different kind of applications, everything from kind of cloud workloads to things like you mentioned, like Abacus. Uh, do you see a sweet spot for ScaleMP going forward, where maybe that customer mix starts to settle into more technical computing or more to the cloud, or what would you foresee?
In fact, I believe that this technology has a place in many other domains that we haven't touched on. We started years ago focusing on the technical computing space because that's where the early adopters are. When you go to a customer that's doing data warehousing or analytics, and you're offering him a software-based SMP to be able to process more data, since it's enterprise space, they're more cautious. They take slow decisions. They trying to stick to traditional solutions. The HPC customers, technical computing customers, are more the early adopter side of the house. So if you look on ScaleMP, when we started, we were focused on manufacturing workloads mostly. Over time, it grew into healthcare, the life sciences segment. And then for weather simulations, which you ask yourself, weather simulations, many of them distributed, why you need that, but there are quite a bit of reasons. It's accelerating the I/O, it gives you the ability to put things in memory. And then outside the technical computing, going into enterprise with big data analytics and with data warehousing and with desktop virtualization consolidation, right? It's completely out of the scope that you and I discussing for years. So in fact, I see it's getting broad. I see our technology broadening in focus rather than shrinking in focus, and I think that that's encouraging. In fact,
So, kind of a wrap-up question here, Shai. You've got this big deployment coming up at Daresbury, a very large supercomputer. And when they plan, how are they going to use that? I mean, will your software be part of their main workload, or will they have to like reboot, set up for a big scale MP job to run like a certain astrophysics? How will that work?
so first of all, this is a centralized computing resource. It's going to be used by many scientists from different organizations at any given point in time. The beauty of the way the infrastructure is being set up there is that when that will be up and running, which is in the next 3 to 4 months, to my understanding, you will be able to submit a job for the infrastructure they provide, and the infrastructure will shape itself. The provisioning tools of platform will be able to allocate multiple nodes that fits to the size of your workload, create a VM, and within a couple of minutes, create a VM that has the right number of cores and the right amount of memory and the right amount of scratch that fits your workload, install the operating system there, accept your workload, run it, and wait a couple of hours or the few days your workload is running and give you the results back. So you can literally get the maximum capacity there is 48 terabytes of memory and 6100 cores. Um, all these number of cores can be configured in different size of shared memory machines, whether you need half a terabyte, or 10 terabyte. The infrastructure can automatically configure it on a per job basis. The beauty of that is that it gives you what you need at the most effective way and not and basically without user intervention, which bring the efficiency of the resource up.
Well, great. Well, Shai, I think that kind of dynamic computing capability is very exciting, and I'm looking forward to hearing more about that and your announcement at ISC. So, thank you for coming on the show today.
And thanks for having me.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.